All right, so let's take a look at this. See what we can remember about graphing f of x equals x squared. How do we do that?
Well, first we pick our x.
We pick some x's. So a lot of times we'll do this just by making a table. What x's should we pick?
I did -2, -1, 0, 1, and 2.
That is an excellent set of choices. Because what do we get when we put them through our function for our x squared here? Bless you. What is -2 squared? If I was to take this -2 and substitute it here, what is -2 squared? What's -2 times -2?
I want an answer, but
I know, nobody's brain's booted up yet. What's -2 times -2, y'all?
4.
4. Boot your brains. Let them start up. What's -1 times -1? Oh, y'all, we're in for a rough day if we can't do this kind of math this early yet. -1 times -1 gives us 1. There we go. 0 squared. There we go. 1 squared is 1. And 2 squared gives us 4. I know it's early on a Monday, y'all, but we do have to school. Sorry. It's not my choice on the time. But this gives us our points to plot up. So we've got our -2, +4 gives us a point up here. My -1, +1 gives me a point right here. My 0, 0 is a point right here. Holy cow, I just got like 6 emails. What are they? No, nothing important. Like 3 field trip reminders. Like, I don't have anything to do with those. Yeah. No. So we get our points that look like this. So when we connect them up, this looks kind of like this, right? Vaguely familiar. What is the domain for this function? What x values could we pick? This domain is all about our x values. What x values could we use? We picked 5 here. Is that for any particular reason? No. Could I have picked any number in the entire existence of the universe? These 5 just make my life a little bit easier because they're a good view of the middle. So we can use absolutely any number from -infinity to +infinity. That's our domain. You could also say all real numbers. That kind of stuff. What's our range? Where did everything wind up? So,
0 to +infinity?
yeah. So our y values, where things landed, 0 is our very, very smallest. And it goes all the way up to +infinity. Or you can say that my y's have to be greater than or equal to 0. That is another way of writing it. Because it starts here and it goes up. My domain could go anything from here to here. Because what we're going to be looking at today is we're going to look at doing some graphing with our exponentials that we've been working with. So let this be the thing that booted up your brain so we can use our brain for the rest of it. Okay, questions on this stuff? Because we just got to hop right into it. We're going to explore a little bit on this and figure out what these darn things look like. So we're going to start by trying to graph 2 to the x. 2 to the x is our first one. Get us some graphs. All right. see if we need more.
So you're sorry that you have to do math for Survey in my head, and you went to Anne Boleyn's song.
I'm sorry. It's such a good song.
My favorite Jane Seymour and Parr. Because they're both
Heart of Stone and Survive, and I don't know about. All right. So what we're going to do is we're going to approach this 2 to the x very much the same way we did in the bell work one, where we're going to make a little table. We're going to pick some x's, and we're going to see what happens. So when we're looking at a graph and we're trying to figure out how it looks, what are some good options for us to start with? What are some good values for us to use to see what's happening? When in doubt, get 0 in there. Figure out what's happening right in the middle. Maybe we pick a couple that are bigger, like 1 and 2. Maybe we pick a couple that are smaller, like -1 and -2. If we need to go further out, we totally can. But that gives us a good view of the center. I will probably do a few outwards from that just so we can see what's happening on this one. But those 5 are going to be kind of our main ones. So these bottom 2 are honestly usually easier for us to figure out because we're doing something like 2 to the first. What is 2 to the first as a value? What's 2 to the power of 1? 2. What is 2 to the power of 2? Because we're substituting in place for this x. What's 2 squared? 4. So then if we go the other direction, it's a little easier to think about it. Now if we go 2 to the 0, not 0. Anything raised to a 0 power is 0. Type it in the calculator. Most of the yellow ones are back on the thing. I just cleaned them off with Lysol on Friday. 1. Anything raised to a power of 0 is 1. Anything. What about 2 to the -1? What about what our negative exponents do? What do? We dealt with them a lot last week. What does our negative exponent do? You can also type it in the calculator. 2 to the -1. 1/2. That's when we get our flip, our reciprocal. So 2 to the -1 is the reciprocal of 2 to the first. So 2 to the -2 is 1/4. That's not how we write 1/4. So that, again, it gives us points. We've got my -2 1/4, which is going to be here-ish. -1 1/2. 0 1 1 2 2 4. And we can really see what's happening on the right. This is really going swoop and going up. Pretty easy to see. What's happening on the left? It's getting smaller and smaller and smaller. Is this ever going to go negative? As you say, if I take 2 to the power of -100, is that going to be negative? No, it's going to be teeny, 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 tiny. But it is never, ever, ever going negative. So this is going to stay kind of sideways like this. Because my graph can never go negative. So what is our domain for this one? What x's can we use? Negative infinity to positive infinity. I had no rules that stopped me from picking anything we wanted. What is our range? Our y's. It goes up to infinity, absolutely. What's the smallest it's gonna be? I was like, it does go smaller than our 1/4. What's it getting really, 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 really close to?
0.
0. So it gets real, real close to 0. Does it exactly equal 0 ever?
No.
No, it just gets really, really close. So that's when we put a parentheses on it. Yes, dear. I don't. I can actually pass the bathroom. Okay. So when we have these pieces here, it's stopping it from going down into the negative. We are going to have a new vocab word that comes up with kind of our bigger year there on what blocks it. So when we're working with these, and when we're working especially with transformations, where I start to move things around, we need to know that word. So is anyone questions on this graph before I put that word up on the screen for us? Because an important word, this is going to be something we work with in just about every chapter from here to the end. It's called an asymptote.
I don't know why that would be.
Because it starts asymptote. It is not uncommon for there to be a giggle. It does not have an abbreviation. We will call it asymptote the whole time. I really want you to have 2 passes. Okay. All right. And what an asymptote is it's like a wall. That is kind of my visualization for an asymptote. It cannot cross. Can't go through it. Can't go over it. Can't go around it. It is a wall. Cannot go through the wall. So when we have an asymptote, do not cross it. Cannot. I can't go through the wall. They are walls. Asymptotes are walls. Don't go through the wall. So, when we are doing asymptotes, especially once we get into transformations, we're going to have it as a y equals because we have horizontal asymptotes right now. So what we're working with today, we're going to work with some of our like parent functions on this, kind of giving us our home base for these. Tomorrow we'll probably do one on our Teams call, and then we'll have Wednesday where we do a bunch. Sorry, I had a breath from pushing on my wall. I was like, I used to do it against that cabinet and made a really good thump, but it's now behind everybody, so that works. Okay, so we're going to be working with these asymptotes. They're going to come up in every chapter between now and the end. So we're going to see asymptotes a bunch. Where these come up is these are going to be what stops our graph from continuing down for forever. So let's do another one of these. We're going to do 3 to the x. We're going to find our x's that we want to use. We're going to substitute them in. We're going to graph it. And we're going to figure out our asymptote. So with all of these exponential functions, we're not going to have like one parent function like we did with like quadratics, where we had the one guy and we'd shift that around. Every time we have a new base, we're going to need to make a new parent function. So this one is 3 to the x. So we're going to use this to figure out our graph. We have to figure out our parent function each time. So we pick our x's to find our y's. Our best options for when we're picking these x's are going to be those same ones we use every time. -2, -1, 0, 1, and 2. The only time we don't use those guys is when we had square roots. Literally, that's the only time we didn't work with them. And to get our y's, you can type them in the calculator. You just got to be careful. We're going to have our 3 to the power of minus 2, 3 to the power of minus 1, 3 to the 0, all those pieces. We can type them in the calculator. Yes, my dear. They are out there just over there by the flags. I just put them in the bin because I ran them through the sanitizer on Friday. So they're on the counter over there by the flag. Yeah, I clean them. I try to keep you guys healthy. You guys get the cleanest of the calculators ever. Because you get them straight out the bin. Because what is 3 to the power of minus 2? 1/9. It's 1 over 3 squared. Or 1 over 9. 3 to the power of minus 1 is 1 over 3 to the first, or 1 over 3. 3 to the power of 0, anything raised to a power of 0 is 1. 3 to the first is 3, and 3 squared is 9.
That's off our graph.
It is off our graph, but that's okay. That is going to happen with these because with exponential functions, they grow so big so quickly. Unless we only worked with 2, we would not be able to get things to lock in on the graph. Or I'd have to give you gigantor graphs.
I just guesstimated.
Yeah, that's exactly what we're going to do. We're going to guesstimate. So we're going to have our -2, 1/9. Yes, my dear.
Sorry, quick question.
No, go ahead.
Can I pass back the quizzes to my DC class?
Yes.
Oh, your kids are taking them too?
I was saying any of them that haven't.
Okay. I just wanted to make sure
Yeah.
I didn't pass them back.
No, I'm with you. Yep. So -2, 1/9. -1, 1/3. And we're estimating. We're getting close. My 0, 1, 1, 3. I know, I'm hysterical. And 2, 9. Which is off our graph, which we can estimate, or we can go, well, it's up there. Yonder somewhere. Point and arrow. That gives us kind of our shape here. It's going to look kind of like this. It's going to look something like this. What is our domain on this? From -infinity to positive infinity. And what's our range? From 0 to infinity. And this is never going to be negative because we have an asymptote. Our barrier, our wall, the thing that this can't go through. I have an asymptote right about there, right? What about there? This is never gonna, this is never going to cross this line right here. We have a horizontal asymptote at y equals 0. We have an asymptote at y equals 0. We always write our asymptotes as equations. Do not tell me your asymptote is 0. Your asymptote is at y equals 0. Because it is a line. What the asymptote gives us is this kind of invisible wall right here that it cannot cross. And when it comes time for us to graph asymptotes, that's exactly how we'll graph them, is as dotted lines, which we will do tomorrow for sure. We have teams. I'll do one with transformations on it, and then we'll do more on Wednesday for them. I just want us to do, actually we might get to one today, honestly, another time. We're doing okay on time. Let's do one more like this, and then I'll show you why we have all these pieces that we care about. So what happens if we have our base of 1/2? So let's see what this looks like. So we're going to pick those same x values. I highly recommend you use those ones. They give us a really good idea of what's happening. We're going to use our -2, our -1, 0, 1, and 2. Those are always a safe bet with what to use. What do we get if I take 1/2 and we raise it to the power of -2? We get 4. What about 1/2 to the power of -1? Because remember what the minus does is it makes it flip, right? So our -1 on the 1/2 means we're going to get a 2. 1/2 to the power of 0, absolutely anything raised to the power of 0 is 1. 1/2 to the first means it's exactly what it is right there, 1/2. And 1/2 squared, 1/2 times 1/2 is 1/4. So if we plot up those points, -2, +4, -1, +2, 0, 1, 1 and 1/2, 2 and 1/4.
It's like the opposite of our first.
Yeah, it looks real similar to that first one we had. In fact, if I go back and forth between them, what do we notice that's different? Yeah, it has a reflection across our y-axis because what this is that same base. That's the same thing as 2 to the -x. It can do that horizontal reflection across that y-axis. They have the same values, and if you look at our tables, they're just flipped here. It's the exact same pieces. What is our domain for this one?
Would this one be flipped because we're going up? Or would we still have negative infinity?
Still negative infinity to positive infinity. Because it's all about what x's can we use. Doesn't matter what's happening to them. If it was end behavior, that's when we would have a thing that was weird like that. Because here we have our end behavior on the left that's going to infinity. And the one on the right, it's not going to infinity or negative infinity. It's actually going to 0. But our range here, still the same as the other ones have been. My very smallest is almost 0. So we put our 0 with our parentheses, and it goes up to infinity. And it's never negative because we have an asymptote at y equals 0. So our first step when we're graphing these is to make our parent functions. That's what these guys are. But that means if we have parent functions, we've got transformations that are going to happen. Which means we've got a transformation form. Which means, I didn't put the slide there, so we're going to write it. In order for us to be able to do transformations, we're going to need to know that our f of x, our graph, we will have our a times b to the x minus h plus k. This is our very last form of equations for this chapter. Finally, the last one. Again, we will give you all of the forms on the test. We just have to know how to use them. This is the only one we get that have a, h, and k in it. Luckily, a, h, and k are fairly familiar friends. We've worked with them before when it came to graphing stuff. They, again, have all the same jobs they've had before, where A tells us if it's going to stretch or compress. We've got our H that is inside has that opposite sign that does our horizontal shift, left and right. And our K at the end that does our vertical shift, up or down. When we are doing the graphs of these, with these transformations, the place we start is with our parent. And our parent is going to be different for almost each one of these graphs because our parent is going to be the b to the x. Whatever our base is, we're going to need to make the parent. So we're going to do one of these today. And I know I used other graphs so much better than singles. But mostly that's because I didn't want to print this out as an individual set. I have these giant piles of graphs over here. So I'm recycling. Clearing out some of my stash of graphs. If you get one that has like no lines on it, let me know. I can get you more. So here's two more. One more graph for everybody. This will be the last one. If you get one that has terrible quality. Okay. Granted, a lot of us have empty graphs right now anyway because we're just observing, I guess. I don't know. Yeah, great, your choice. That's for Friday. I'm just saying, when I see 3 blank graphs on a page right now. All right, let's do one where we're looking at these kind of stuff. So we're going to do 2 to the x plus 1 minus 3. This is our graph we're going to do. A lot of times we will tell you to graph both of these. And what this one is, f of 2 to the x, we've graphed this one already today. This is our parent.
So that's our new parent function?
When we have a transformation here, this piece, our whatever number is our base, that's the parent we're working with. So this is 2 to the x plus 1, which means my base, my parent function needs to be 2 to the x. So that's the guy we're looking at first. We've done this one already today, but not since we started talking about what the heck an asymptote was. So when we do these and when I'm filling in my parent functions, I will use those same x's we've been using, my -2, my -1, 0, 1, and 2. For our 2 to the x, 2 to the power of -2, that's our 1/4. And if we need to type these in the calculator, that's absolutely valid. To get our second graph, we won't need calculator hardly at all. Our 2 to the -1, we get our 1/2. 2 to the 0, anything raised to a 0 power is 1. 2 to the first is 2, and 2 squared is 4. And this is going to have an asymptote at y equals 0. I'm just going to put it right there at the bottom. If we were to graph this guy, it's not there. This one. So that's what this piece looks like.
We're using dashed lines for the other one, right?
We use dashed lines usually for the asymptote part. I will show you what that's going to look like when we do the transformation. Okay? Because oh, that is easy to fix.
My brain is not working.
If you ever need more than one color, I've got you so thoroughly. Pick a color, any color.
Thank you.
I have vast quantities. If anyone else needs another color, I got your back. Because what we're going to do is we're going to look at this equation here, our g of x. This guy's our f of x. We're going to look at our g of x, and we're going to figure out what's our a, what's our h, and what's our k. So the 2, that we know, that's our base. That's what we graphed. That's our parent function. That's how we decide this guy, the base. Looking at g of x here. What's our a? What number is multiplied in front of our base? I heard someone say it. I just started talking at the exact same moment as you. 1. Yep. That's the same thing as if I put 1 times. So if there's nothing written out in front, our a is 1. How about our h? X minus something in the exponent. Our h is going to be what? Think of it like our factors. -1. It always has that opposite sign. H is the opposite. It always has an opposite sign. Whether it's quadratics, whether it's anything. How about our k? K is tucked on the end over here. So what's our k? -3. What does a k of -3 tell us is going to happen? It's going to go down. This whole thing is going to go ka-chunk, 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 down 3 spots. So this whole thing is moving down. My h of -1 tells me it's going to go which way? Left. It's going to go left 1. So what we're going to do is we're going to take our table and we are going to apply our transformations to it. So I'm going to take my table, and this is when we take our x. In fact, I'm going to change. I'm going to use my blue x because it's for my parent function. And then we add h. And then we always remember how much graphing makes us yak. Y times a plus k. Because graphing makes us yak. So in particular on this one, we're going to take our x's from our parent function and we are going to add -1. So plus -1 means -1. We're going to take our y's from our parent function and we're going to go times 1, which doesn't really change much, and then -3. So anything that has a y gets times 1 and then -3. So if I take my -2 and we subtract 1, we're going to get a -3. -1 minus 1, -2. 0 minus 1, -1. 1 minus 1 is 0, and 2 minus 1 is 1. We've done AH and Cam before. For our, whoa, not the laser pointer. For our y's over here, we might need to use a calculator for it, especially when we have a values, but we can do that. We're totally awesome. We're going to have our 1/4 minus 3. Might need a calculator. That's okay. What is 1/4 times 1 minus 3? A mixed number. Totally fine. You can do it as a mixed number. You can do it as a decimal.
I don't know which one.
The 2 arrows above the enter key puts you back into a decimal.
I know. It's just I don't know.
Decimals are sometimes easier to graph.
Well, the decimal is -2.75.
Mm-hmm. Yep, -2.75 is right. If we do 1/2 minus 3, look at it, -2.5. Once we get down to this one, oh yay, we're out of fraction land. 1 minus 3, -2. 2 minus 3 gives us a -1. And 4 minus 3 is a +1. we're also gonna put down here our y equals for our asymptote, and it's going to be our y equals k. Y equals -3, because my asymptote is also gonna go down 3. So the asymptote's involved in there. When it comes time to graph these, we can plot up our points, but we're not connecting them until we get the asymptote on the graph. So you can do it in whichever order you want. If you like to plot your points first and then do your asymptote, totally valid. We'll have our -3, -2 3/4, -2, -2.5, -1, -2, 0, -1, and 1, 1. So my dots all look like this. Important thing for us to get on here is that this is my wall. This is my barrier we cannot cross. Y equals -3. I'm going to draw that right here. Asymptotes we draw with dotted lines. This guy is that guy. But doing that lets us see our wall. I can get real close to it. I can push on it, but I'm not going through the wall. The line is not going through your dotted line. My black line is not going through. Do not cross our asymptotes, but it's gonna look like this. We took our whole graph. We went left 1 and we went ka-chunk, ka-chunk, ka-chunk down 3. Okay? We will practice more with these tomorrow. We'll do one more like this with the transformations. And then you guys are going to have a skills check on Canvas. So we will do one graph, and then you guys will have a skills check. And then Wednesday, we'll do a bunch of these. Bunch of cruncher. And then we're reviewing for the test. Okay? So I'm going to get our announcements up. I have for you guys 2 lovely presents. I know everybody's favorite. The last homework. Yay! The chapter review. Aww. Okay, so I'm going to pass them both out so you can have them. And I'm going to put announcements up. And that's it.